In this video, we will calculate the frequency and wavelength of light that has an energy of 7.66 times 10 to the negative 25 joules. And so the equation that relates energy to frequency and wavelength is where energy is equal to h nu, where nu is the frequency, or energy is equal to hc over lambda, where lambda is the wavelength of the light, and c is the speed of light. H in both of these cases is Planck's constant, which is 6.626 times 10 to the negative 34 joule seconds, and c, which is the speed of light, is approximately equal to 3 times 10 to the 8th meters per second in a vacuum. If we plug our values into these equations, so in the case of frequency, we'll have nu is equal to E over h, where that is then 7.66 times 10 to the negative 25 joules, over 6.626 times 10 to the negative 34 joule seconds. What we can see is that the joules will cancel out, and our frequency is going to be 1.16 times 10 to the ninth 1 over seconds, or hertz. To calculate the wavelength of light, we'll use the equation lambda is equal to hc over E, which then comes out to being 6.626 times 10 to the negative 34 joule seconds, times 3 times 10 to the 8th meters per second over 7.66 times 10 to the negative 25 joules. And so we can see that the seconds and the joules cancel out, and so the wavelength of light that we will have is 0.260 meters. So within this video, what we were able to do is calculate the frequency and wavelength of light from a given energy.